Welcome to lesson 4.2.1, and in this lesson we will be looking at the unit circle and problem solving. If the point P, 4, -3, is a point on the terminal arm of a rotation angle, determine the exact values of the 6 trigonometric ratios of the rotation angle.
Okay, well, to answer this question, probably the smartest thing we can do here is plot this point and get a sense of what this looks like, this little scenario here. So let's take a quick look. So we'll draw our Cartesian plane here. And now we know that the point is the point 4, -3. So 1, 2, 3, 4. And then 1, 2, 3. So our coordinate here for P is going to be down here in the 4th quadrant. Okay, and this is our point 4, -3. So let's just connect that out, draw our terminal arm in there. And so the angle that we're looking at is this guy right here. Typically we're looking at angle theta in standard position. Okay, now let's draw our triangle here, because remember, trigonometry is always based off of a right angle triangle. And in these questions here, the triangle that we want to draw, remember that we're always going to drop the altitude towards the x-axis. Okay, we always do it towards the x-axis. I've seen people that want to do it towards the y-axis. That changes the definitions, that changes everything. You don't really want to do that. Okay, everything that we've done here is consistently defined when we drop the altitude towards the x-axis here. So now what we got to do is we got to figure out what the value of our hypotenuse is. We know that this length right here is going to be -3, and we know that this is going to be +4. So let's just enter that in. Okay, one of the defining relationships here between the coordinates of that point on a terminal arm is the Pythagorean theorem. Okay, so in this case we know that x is 4, and we'll know that y is going to be -3 is equal to r squared. Now, I suspect that there's going to be a whole bunch of you out here that know what the answer is to r without having to go through this step here. The reason why I'm putting this out here is I want to just focus really quickly on using the Pythagorean theorem here, something to help you guys out here, because it's not always going to be these nice numbers, okay? It's not always going to be 4 and -3 or 4 and +3 here. And I want to focus on this part right here. I've seen lots of people, especially when they go to their calculators, that won't use the parentheses there. When you square this number without the parentheses, you'll get -9. But the truth is, when you square a negative number, you should be getting a positive result here. You need to have those parentheses here to make sure that the calculator understands that you are squaring the negative and the 3. And when we walk through that, 4 squared is going to be 16, -3 squared is 9. There's my r squared. Add those together. So 25 is equal to r squared. And I'll take the square root of both sides here. And normally in a situation like this, you would get r is equal to ±5. But, okay, little note here. Note that r is always is always positive. Okay, there's no nice positive negative orientation for r, so we just always consider it positive. So that means therefore, okay, we're only going to take the positive value for that. So r is 5. Now we've got everything we need to answer these questions here. So just take a quick look at this diagram here on the Cartesian plane. Notice that our x value here is 4, our y coordinate here is -3, and now we know that r here is equal to 5. So now we can put those all together here, because we know that the sine of theta should be the y coordinate over the r value, so y over r, and so that's going to be -3/5. And at the same time, once you know what sine is, you know immediately what cosecant of that angle is going to be. Okay, it's going to be the reciprocal of that, r over y. So in this case, that would be -5/3. Cosine is going to be that x coordinate, okay, the x value, so that's going to be x over r, and in this case that will be 4/5. Notice that it's positive, and we expected that because it's in the 4th quadrant. And then the secant of theta is going to be r over x, so 5/4. And then finally the tangent of theta is going to be y over x, so in this case -3/4. Whoops, sorry, I was going to write tangent again. That's not what I want to write. Cotangent. Cotangent is going to be x over y, and so in this case 4/-3, but I can move that negative wherever I'd like, so I'll make that -4/3. And so those are the 6 trigonometric ratios that we're looking for this rotation angle.
Determine the missing y coordinate of point A, negative 8/17, y, if A is on the unit circle and is in quadrant 2.
So what you want to do when you get a question like this is make sure you've read everything, okay? We want to determine the missing y coordinate of that point there, A. So my x coordinate is negative 8/17, and my y coordinate is the unknown here. But they give us a little bit more information, and you'd be missing out if you didn't continue to read this. So first of all, we know that this is going to be on the unit circle, and we're told specifically that we're in quadrant 2. Okay, so there's obviously some information that we're being given there that we need to pay attention to. So let's just zoom out a little bit here. So to start off with, just remember here that the unit circle, okay, the unit circle has the equation x squared plus y squared is equal to, now not r squared in this case, as we've done over and over again, but 1. Okay? The unit circle is named because the radius is a single unit. So x squared plus y squared is equal to 1. So in this case here, we can take the x value of that point and the y coordinate that we don't know, and we can put that into this equation here. So thus, we might write negative 8/17 squared plus y squared is equal to 1. It's actually a really nice little equation there to solve. Okay, negative 8/17 squared will be 64/289 plus y squared is equal to 1. And now I'm going to bring that numerical value over here. I've got 2 terms here. There's my unknown, okay, in this particular term. So I need to move the other term over. It's positive on this side, so I'm going to subtract it from both sides. And that'll get me y is equal to, okay, well 1, bear in mind, 1, and I know that not everybody loves to work with fractions here, but just bear in mind that 1 is simply going to be 289/289. So when I subtract 64 from both sides, I will get 225/289ths. Okay? And now I will take the square root of both sides to eliminate the square on the thing that I want to know here, the variable here, y. So y will equal the positive or negative square root of 225/289, which ends up being this nice number. Well, it's not really nice, but it's a relatively nice fraction there, 15/17. Okay, great. Except now I've got 2 answers here. Okay? And I got to think about that. I've got 2 answers here. So which one is it? Is it the positive or the negative? Well, that's what that other bit of information was. Okay? Remember that we're told that A is in the second quadrant. So A is out here. Here's our terminal arm. So here's A. And bear in mind, again, we were told that this was going to be negative 8/17. Here's our y. Because we're in the second quadrant here, we know that y is going to be positive. So therefore, okay, since we are in quadrant 2, y is positive. Thus, y is equal to positive 15/17. That's what we were looking for.
If point P, negative 0.7660444, 0.6427876, is a point on the unit circle, then, to the nearest tenth of a degree, the point P lies on the terminal arm of angle what?
So in this case right here, again, it's a matter of reading everything here. So we're given this point here, and wow, I mean, look at that point there. You got some big decimal values going in there. But remember, this is just still an x comma y, right? There are just 2 numbers here. Granted, a little bit more complicated, but they're just 2 numbers. And it's a point on the unit circle. Now let's go through and let's just think about what that means. Okay, so I'm going to draw the unit circle here, and we're going to put a point on there. Now, the important thing to remember when you're dealing with the unit circle is that the radius is 1. So this is the point 1, 0. This is the point 0, 1. Over here, this will be negative 1, 0. Down here, this is the point 0, negative 1. Okay, the radius here is always 1. So when I come out here and draw my triangle, so I can deal with the trigonometry here. Okay, this is going to be x, this is going to be y. Bear in mind that in this particular case here, our definitions are very, well, very convenient, I guess is the best way to say it. The definition of the sine of this angle here, theta, in standard position, here's theta. The definition of the sine of that angle is going to be the y coordinate over the r value, okay? Y over r. But in this case, r is just 1, so this becomes y. And cosine, likewise, which would normally be x over r, is simply going to be x. So that point right there, that x comma y, is actually going to be the cosine of the angle in standard position, comma, the sine of the angle in standard position. In fact, sometimes when people approach trigonometry, one way of approaching it is to actually think about sine and cosine and tangent here as being the values of the coordinates along the unit circle. Instead of defining it, for example, as opposite and adjacent and hypotenuse and blah, blah, blah. Here's another way of thinking about it. Okay, you could define it as the points along this circle. So anyway, with that in mind, what we know then is, coming back up to here, is that this number right here ends up being the cosine of the angle, and this ends up being the sine of that angle. So therefore, we know that the cosine of the angle that we're interested in here is going to be this negative 0.76604444. Additionally, the sine of the angle is going to be 0.642786. Okay, now, a couple other things we got to look at here. Now, let's go back to the point here. Notice that the x-coordinate here is negative, the y-coordinate is positive. Okay, x-coordinate is negative, y-coordinate is positive. So we're out here. Here's our theta out in standard position. Our angle's in the second quadrant. Okay, so that gives us a little bit of information here. Now, regardless of which one of these I choose, I'm going to look for my reference angle. And it doesn't really matter which one I use here. I could either do the inverse cosine of, now I would take the absolute value, okay, of the ratio, the trig ratio that I'm using. In fact, and it should be the same regardless of which trig ratio I use. And again, I'm going to use the absolute value. Now, the reason I'm going to use the absolute value here is just that I've got this negative in front of the ratio here. Well, it turns out the calculator is programmed to handle the negative differently depending on whether you're looking at sine, cos, or tan. Now, I can get around that by simply knowing how the reference angle gets placed in the different quadrants, okay? And you're supposed to know that anyway. So just use the absolute value here so that you're always dealing with a positive ratio. The negative tells you what quadrant we're supposed to be in. We already know that. So the negative really isn't serving much of a purpose here. Whether or not you use this ratio or this ratio, we're going to find here that the alpha here, the reference angle, is going to be 40 degrees. So in quadrant 2, okay, here's our angle. We know now that this is going to be 40 degrees. And let's just think about that. What angle would I need to put here to get me an angle of 40 degrees? Well, that's got to be, theta has to be 140 degrees so that the sum of those two is 180. That's the angle that we're looking for.